There it goes. All right. So it's right above example 3, but let me just show you one thing and show you how to use it. We're probably going to explain this more through the example than anything else. So when we talk about composition of functions, right now we haven't really done the composition. All we did was learn how to add, subtract, multiply, and divide functions, okay? And we kind of made it a little shorter way of writing it. This is review right here. This is nothing new. I'm not going to do all 4 of them, but this is what we did on Friday. Okay, we just started off. We said f plus g, right? F function plus the g function of x. What does that mean? That means we just take the f function and add it to the g function. So f of x is one function, it's the f function. G of x is the g function. So that's what we learned on Friday. Today, we're going to learn a little bit more, and this is where we're going to actually do the composition. We haven't done composition yet. This is going to be the composition of functions, and I'm just going to write it out for you. So here it is. It's f, and then we put a little circle. It's not a dot. It's not multiplication. This little circle means composition, all right? So I'm going to write like this. This means something completely different than f of x times g of x. This is an open circle, okay? It's not really, really big, but don't make it too tiny. Make it big enough so you can see that it's an open circle of x. Here's what it means, and that's all this is basically the definition. I'm going to show you what it means, and then we're going to do some examples. It's really pretty easy. It's not much more difficult than this stuff right here, but at first glance, you probably won't know what to do unless you see what I'm going to write right here. So this is what it means. So f composition g means this, f of g of x. So what we're doing, we're taking a function and we're putting it into another function. We're not just adding 2 separate functions. We're not just multiplying, subtracting, dividing 2 separate functions. We're taking a function and we're putting it into another function. You're like, that makes no sense to me. I get it. Okay, what I just said right there. You got to see the examples and see how it works. But this right here is basically the definition of the composition of functions. So that's really, really important. Now you could write it another way. You could use any letters at all. What if I said g composition f of x? How do you think we would write it out here? G of f of x. Okay? Right? You can put any letters in there, but that's what it means to do. Most of the time in math books, they use f and g. Once in a while, they'll use some more, but most of the time they use f and g for these functions. So let's do an example. This is example A. So this is example 3 and part A. So it says, I'll tell you what, let's get rid of the A right now. So we say find, and you're going to find that it's not as difficult as it looks. It really isn't, I promise you. So we're going to find 2 things, both of these functions. So I'm going to write it down, f composition g of x and g composition f of x. All right? For the given things. All right, so here's the 2 given things. It says for, F-O-R. They're going to give you the f function, and they're going to give you the g function. So this is what the first one is. It's 2x cubed minus 3x plus 8. They didn't start off like super simple. I thought they might start off with just a little bit easier examples as these, but that's okay. We can still get it. And g of x is 5x minus 6. Now this is what they tell you. There's no way I know that f of x is that and g of x is that. They tell us this, okay? What are we finding? We're finding 2 things. We're finding, number 1, f composition g of x, and then number 2, we're finding g composition f of x. So we're finding 2 things, all right? Both of these things right here. This is the f function. This is the g function. All right? So let me just show you how we're going to set this up. Do you remember what f, we'll write it right here. Do you remember what f composition g of x means? You got it at the top of your notes. It It's f of g of x. So what we're doing is we're taking the g function, we're putting it into the f function. So wherever we see an x in the f function, what are we going to put into it? The g function. So what we're doing is this. It's basically a glorified substitution. All right, it's just another way to show substitution. It's just a little more streamlined. It looks a little bit better. It's less wordy and that kind of thing. That's basically what it is. So what is the g function that they give you? 5x minus 6. So we're going to take that and we're going to put it into what? Well, into f of x. So we're going to take this and put it in for x. We're going to take this and we're going to put it in for x right there. That's what it means. So we take the stuff that's in the g function and you put it into, you substitute it in for the x in the f function. Everybody got that? That's not too hard to understand, is it? Now, it gets a little bit cumbersome here, and we are going to do a little bit of math here. That's why I said I'm surprised that they start with something quite as involved, but the idea is not that bad. I got to put this down so we can see. All right, so let's do this. So I'm going to put f composition g of x is equal to, all right, now let's do it. What are we going to do? We're going to go, let's just take what's in here and put it in for here. So what are we going to write? 2 what? Are we just going to write x cubed? What are we going to put in for that x? What's the whole entire g function? 5x minus 6. We're going to take that whole g function. See, I circled it right there so you can see it. I circled it, right, because that's what we're putting it in for the x. So instead of x cubed, what's it going to be? 5x minus 6. In parentheses, what? Cubed. And then a 2 out in front. See what I'm doing? All right. So I'm just taking that whole g of x, and I'm substituting it in for the x in the f function. Okay? It's just substitution. So I'm going to write a 2. I'm going to put a parentheses. What do I replace that x with?
2.
No. 5x minus 6.
I saw it in my head.
I know. Because you answered it earlier. You answered it correctly earlier. So, and then what do we do to that parentheses?
Cubed.
Yeah, you got to cube it. That's where it gets a little ugly. Is it cubed? It's not cubed. It's squared. Oh, thank goodness. I was going to say, oh my gosh, I don't want to cube that thing. So change that to a squared. I looked at that thing and I thought, why are they going to, I mean, we could cube it, but man, it's going to be a mess. Squaring's not so bad, all right? Cubing and more than that is way worse. All right, let's keep going. So we took that x and we replaced it with a 5x minus 6. What are we going to do here? Let's write out the rest of the f function. So it's minus 3. And then parentheses, what do we put in for that x?
5x minus 6.
Look, this whole thing's circled. We're not splitting it up. We're not splitting it up. This is all one thing, okay? This is all one thing. That's your entire g function, okay? Your g of x. So we're taking that whole thing and we're putting it in for this x right there. So it's minus 3 times what? 5x minus 6, thank you.
Plus 8.
And then we put the plus 8. Yeah, there's no x there, so there's nothing to replace x with in that one. So now we just do some math. So setting it up was the new stuff, all right? Everything else we do from here on out on this problem is the old stuff, okay? It's just Algebra 1 stuff and Algebra 2, okay? Yeah, it's probably Algebra. You probably learned that in Algebra 1. So let's do it. I'm going to go kind of fast, all right? It's on the video, all right? Write it down. If you have questions about it, rewatch the video and try it yourself. You should be able to figure this out. So 2. What do we do when we square something? We multiply it what? By itself. So I got to take that 5x minus 6, put it in 2 parentheses, right? Isn't that squaring 5x minus 6? Yep. So we have to do that. I can't do this. A lot of people want to do this, but you can't. I almost hate telling you what you can't do because that's what you'll probably remember, all right? But you can't go 5 squared x squared minus 6 squared. Doesn't work that way, all right? What are you doing? You're multiplying that whole parentheses by itself, all right? It's going to be something different. You're going to get this middle term that you wouldn't get by just squaring each individual thing. Let's keep going. Minus, let's do the math here. What's this going to be? Minus what? 15x plus 18. All I did was just take that negative 3 and distribute it right there, okay? Now, the bulk of the work is this thing right here, all right? Do you remember FOIL method? Yeah. Okay. You did a ton of that last year, didn't you, in Algebra 2? FOIL method? Yeah, you should have. Put the 2 here. I'm going to put a parentheses because we're multiplying all this stuff right here by 2. Are we multiplying like everything here by 2? No, just this thing right here. So let's do the FOIL method. First, outside, inside, last. So we multiply the first. What are we going to get? 25x squared. Outside, these two right here.
30x.
Minus 30x, right? Negative 30x. And then inside, same exact thing, right? Minus 30x again. And then the last,
36.
plus 36. Make sure you get the signs right. We can simplify this a little bit, can't we? What's that? Minus 15x, and this is what? 26, is that right? Okay. What did I forget? I forgot the x. Yep.
Yes, negative x.
It's plus 18 because negative 3 times negative 6. Okay? You with me so far? Yeah. Now again, what we're doing right this second right now is not really what we're studying right now. This is just the work to get to the answer. All right? So let's do this. Let's keep the 2 there. What can we do here? Well, no, I'm not going to do that. I want to add like term. I want to add combine like terms, okay? Before I worry about that 2. So I've got 25x squared. What's that going to be? Minus 60x. And then plus 36. And then minus 15x plus 26. That's the only thing we did. We just added those 2 things up. Now we can do what? Distribute, right. So multiply everything in that parentheses. Just in that parentheses, multiply everything by 2. So we get 50x squared minus what? 120x plus, can you double 36 in your head? No?
72.
72, good. And then write down the rest of it. Minus 15x plus 26. It's a little involved, but has it really been difficult? I mean, the FOIL thing, that was the hardest thing we did, and really, that's not that hard, is it? Just got to keep everything straight. Take your time. Don't rush through it. What do we have here? Let's add some like terms. Are there any other x squareds? No, so we just write down 50x squared. I like to mark it off when I'm done, especially when I have a whole bunch of them. I mean, I don't have a ton here, but at least I got a couple things. What do we got here? Negative 120x minus 15x. Yeah, I can add those together. Yeah, negative 135x. So I'm done with that one, and I'm done with that one. What do we got left? Just add that up. 7 and 2 is 9, so it's 98. So that would be what, plus or minus? Plus, because they're both positive. Is there anything else I can do with that? No. That's my answer. But again, I think they gave you too much to do there, because if I was to write this, I'd start off with an easier one, because I'm just trying to get you to understand what this means. F composition G of X. Okay, that's what we're concerned about. Everybody got that? Now, what do we have to do? We had to do this, and what was our second part of this? We had to do G composition F of X. Well, no, got 2 things to do. We got a 1 and a 2. We did the first one. We found F composition G of X, F of G of X. Now we got to find G of F of X.
Cheerleaders are dismissed at 2:30.
Do you think this one's going to be better or worse? So we got to go what? G of F of X. What does that mean? That means we take the F function, right? What's the F function? This whole entire thing. Yep. That, and we're going to put it in, we're going to substitute it in for
G of X of X.
into the G of X function. Okay? So we're taking that thing that's circled in yellow and we're putting it in for that X right there. So I'll keep everything yellow because
It's different.
it looks like a mess. Okay, so here we go. So we're taking the f function and we're putting it into, we're substituting it into the g function. So what do we got? We got 5 times x. What am I putting in for x?
2x squared minus 3x.
Exactly. We're putting in that whole thing. You're going to see that this one isn't quite as bad as the first one. Okay? So that's the only substitution we have to make, right? This had an x. We're putting what the f function is in for the x in the g function. And then what's at the end? Just a minus 6. So it's a simple distributive property, add like terms, bang, we're done. All right, so let's do it. What's this going to be?
10x squared
10x squared minus 15x plus 40. And then minus 6. Add like terms. Well, these are the only two things you can add. So my answer is 10x squared minus 15x plus what? 34. That is the answer. So you had two answers because they asked you two different things. They said find f of g of x and then find g of f of x. Everybody got that? Yeah. Like this way? So that's composition of functions. Now we're going to go back to the domain and range stuff. In fact, I think we just are doing domains on this one. All right, everybody ready for this one? All right, let's go back to white. All right, here's what it says. This is example 4. It says state the domain. State the domain. We talked a little bit about that the other day, right? What the domain meant of, we'll put it right here, f composition g of x for, now they're going to give you the f and the g function. So here's the f function. For f of x equals the square root of x minus 4, and g of x is equal to 1 over x squared. So we're not going to, well, let's see. Yeah, we're not going to do that composition thing, even though it says do the composition. Okay, here's what, I'm not going to write this phrase down, but let me read it to you. It says the domain of a composed function. This right here is a composed function. That's a composition function. Everybody hear that? So the domain of that function is determined by the domains of both f of x and g of x. What in the world does that mean? That means if I can find the domain of this and I can find the domain of this, that's going to be the domain of that whole composition. So really, we don't have to worry about the composition. Basically, all we're trying to do is basically just find the domain of this and find the domain of this. And what does that mean, to find the domain of something? What is it?
X and Y values.
Well, just the x, right. We want to find all the possible x values. Like some domains are all the real numbers, right? You could put any number into a function and it'll work. But there are some things, like this, like a square root and a fraction, that there are things that x cannot be, all right? And so we got to kind of know those. These are the two big ones right here. So if you have a square root, we've talked about this before. What must the stuff inside, there's a name for it, I forget what it's called. But anyway, as far as we're concerned, all the stuff inside that square root has to do something. It cannot, well, it can be 0. It can't be negative, okay? So you cannot have a negative inside of a square root. You with me on that? That's our first start to trying to figure out what the domain of this thing is. So that x minus 4 cannot be what? Negative. Everybody with me? Let's switch gears a little bit and talk about fractions. What can the denominator of a fraction not be? Can't be 0. All right, so we've talked about this already before, right? So basically that's kind of what they're doing. So let's figure out the domain of both of them. And then this next little part, I've worried since I took my notes on how am I going to explain this, but we'll get to it. All right, but we could do this part right here. So x minus, let's just do the domain of the f function, the f of x. So what do we say, x minus 4, what is it, instead of saying what it can't be, what does it have to be? Positive, right. Not just positive, but it could also be something else that's not a positive, 0, right. So x minus 4, let's use less than greater than. So how am I going to write that? X minus 4, very good. Greater than or equal to 0. Agreed? All right. So let's solve for x. So add a 4 to both sides. What is it? X must be what? Greater than or equal to 4. So I'm just going to circle that for right now. Okay. It's not my complete answer, but it's going to be part of it. We're going to use that for sure. And this is kind of easy as well. So x has to be greater than. So what about this? On this one, I think it's easier to say what can x not be. Yeah. All right. So on this one, x cannot be 0. Or I should say the denominator. Okay. The denominator cannot equal 0. So if x was 0, that would make that denominator 0, wouldn't it? Because 0 squared is 0. Everybody with me on that? So in this case, we say that x cannot equal 0. Or we could say x squared could not be equal to 0. So if we solve for x, then that means that x cannot be equal to 0. That's technically what we're doing here. All right, so we're going to use that as well. So those are the domains of those two individual things. All right, let me see what I wrote down. Give me a second. I just want to get my thoughts together here. Let's be true that g of x is... All right. I'm just going to read what I wrote. I'm trying to figure out how to explain this. It says the domain of the f function is greater than or equal to 4. And then I wrote, so for x to be the domain of the composition, it must be true that g of x has to be greater than or equal to 4. I think I'm going to write this down. So for x to be the domain of that composition, it must be true that g of x also has to be greater than or equal to 4. Not sure if I can explain that. I should. Tell you what, let me just, it's probably because of that thing I read earlier where it said the domain of a composed function is determined by the domains of both f of x and g of x. I know you probably don't care, you just want to be able to get the answer that they want you to have. But I need a good explanation. But I'm going to just pause that explanation for right now. I'm going to have to do a little more research into that. It's probably written in the book. But here's what they say. And I wish I had not a better one, but at least an explanation for this. So they're saying that g of x also has to have the same domain as the f of x, I think is what they're saying. So it says the domain of the composed function is determined by the domains of both f of x and g of x. It's somewhere in there. The explanation is in there somewhere. I'm going to have to look at it and research it a little bit more. So, but this is what I ended up with, that g of x also must be greater than or equal to 4. Well, that kind of makes sense, because if right here, if I say x has to be greater than or equal to 4, what's it say?
If g of x is undefined for a given value of x, then that value is excluded from the domain. So it's saying that g of x has to equal greater than or equal to 4.
Right.
Because the x does not equal 0 is excluded.
Right. So we already said that x can't be 0, but there's another thing that x has to be. It has to be greater than or equal to 4. Okay, so g of x, it's true, because look, greater than or equal to 4, does that include 0?
Yeah. No.
No. Any number greater than or equal to 4, 0 is not going to be that, right? Exactly. You got that? So this says x can't be 0, but also that's not like the only thing it can't be. It has to be what else? Bigger or equal to 4. 4 or bigger. So that's why they did that. All right, so it is said in the book. I probably just didn't write that part down. So here's what we're going to do. We're going to say that this also, g of x, it's true that it can't be 0, but there's other things that it has to be for the whole composition to work, because the f and the g work together, right? So they both have to fit the domain. The domain has to fit both of them. So g of x also has to be greater than or equal to 4. Now, here's what we're going to do. What did I say g of x was? Remember what the function was? 1 over what? X squared. Okay. And what we're going to do is we're going to find out what x has to be as well. So we already know it has to be greater than or equal to 4, but x could be something else too. I'll show you here in a sec. Let me just see what I wrote down here. Okay. We probably won't get to the very last thing that I wanted to teach, but that's okay. At least we'll get this far. What if I wanted to solve for x here? What if I wanted to solve for x? I could do a couple things to solve for x. What's good? You can't wait 12 minutes? You can't wait 12 minutes? All right, bring it up here. That's good stuff. All right, so I am not going to take the square root just yet, because this is 1 over x squared, okay? I don't want to take the square root because x is not in the numerator. So let's put x in the numerator. So here's what I do. I multiplied this by x, I multiplied this by x squared, and then what am I going to do to the other side? Multiply that by x squared. Everybody see that? Just to get it in the numerator so I can get it by itself, so I can get x by itself. So what happens here? I cancel out. What am I left with over here on the left-hand side? Well, 1. So 1 is greater than or equal to what? 4x squared. Oh, wait a minute. Yeah, that's fine. I want to get x squared by itself. So what am I going to get rid of here? The 4. So how do we get rid of the 4? Divide. So this is going to be 1/4 is greater than or equal to, that cancels out what? X squared. Now, what'd you guys say we should do? Well, yeah, square root both sides. So I'm going to square root this side, I'm going to square root this side. Now you got to be careful, because when you square root something, don't you get a positive version and a negative version? Yeah, because watch, square root of 9. What's the square root of 9? It's 3, but it's also negative 3, because negative 3 times negative 3 is positive 9, okay? So you got to consider that. Yeah, you could put plus or minus. Now I'm going to do something that's going to be weird, all right? If you really got a good Algebra 2 class, you might have remembered this, but the square root of x squared, it's always going to be, any idea? The absolute value of x. Were you taught that? That's it. The square root of x squared is not just an x, it's the absolute value of x. Because think about it. this has to come out positive. Agreed? So the absolute value, or yeah, if I take the absolute value of x, that guarantees that it's going to be positive. All right? Boom, boom, like this. Now what's this? It's 1/2, but it's plus what? Or minus 1/2. All right? Now, here's a weird thing. I don't know if you ever taught this. I actually taught this in my college algebra class. And this is probably an Algebra 2 topic, but let me just show you. What I'm going to do, if you were to graph an absolute value, watch what we're going to do here. What does this mean? This means x, actually, let's do it the other way. Let's put the x on the left-hand side. If I flipped it, if I read it from right to left, what would this say? The absolute value of x, if I read it, and then I put the 1/2 here. Can I just put greater than or equal to here if I flip sides?
Yeah, flip it again.
Yeah, so I'm going to put less than. And that's say the same thing? So absolute value of x is less than or equal to plus or minus 1/2?
Yeah.
Okay? So that's a little bit nicer way to write it. So if you were to graph something like this, what you would do is you would put the negative 1/2 right there and a positive 1/2 right here. So any number between negative 1/2 and positive 1/2 actually makes this thing work. Let's try one. Give me a super easy number between negative 1/2 and 1/2.
0.
0. Good. Okay. Let's put it in here. Okay. So is 0, what's the absolute value of 0? 0. Is it less than or equal to yeah, is it to either one of these? Is it less than or equal to positive 1/2? Yes, it is. I'm not explaining this well at all. But anyway, this is how you graph it. Okay, so if you have an absolute value, you got the plus or minus, you put 1 here and you put 1 here. So x could be any number between negative 1/2 and positive 1/2. Okay? Let's put a number, let's use a number outside. Let's say we use 1. Okay, put a 1 in there. What's the absolute value of 1? It's 1. Oh man, I'm blowing this. See, I did these notes like 4 or 5 days ago, and I had it down pat for my explanations, and I'm really messing it up right now. If I put a 1, is 1. Oh yeah, okay, that works. What am I thinking? Stupid. I got it now, watch. If I put a 1 in here, I was trying to make it work, but it shouldn't work because 1 is not in between negative 1/2 and 1/2, is it? So I put a 1 in here. Is 1 less than or equal to 1/2? No, it's not, all right? And so if I put a negative 1 in here, see this lies outside? The absolute value of negative 1 is positive 1, still doesn't work, all right? So it has to be, there has to be the numbers in between negative 1/2 and positive 1/2. So the domain of that composition is, I'm sorry, I'm screwing this thing up big time for you. I'm going to study this in a little bit more depth and give you a better explanation, but I'm just going to give you the answer right here. Is what the book says, that x is between, right there, that's what it means when it's in between these, negative 1/2 and positive 1/2. All right, and it also, but 0 lies in there, doesn't it? But remember what we said about that g function? What can x not be? Right, so you got to add that as well. So this is the domain. We'll just put a little comma, and we'll also say that x can't be 0. So that's the that's the domain of the composition of the functions. I'm sorry about that. We were doing really well until we got to this part. And I've always struggled with this a little bit. So I'm going to have to do some research and give you a better explanation of this. You probably won't see a whole lot of this anyway. Okay, it's more of that regular composition stuff. And there's the one thing at the end. It's called iterations. That was something that I had never studied in my life, but I studied it. I watched a bunch of YouTube videos. It's actually pretty easy, but we just don't have enough time today. I need at least 10 minutes, and we've got like 3 or 4 minutes left. Okay, so but we will finish that tomorrow. But I want you to do as many of these problems as you can. Sorry about the stupid problem I had with that domain of compositions, but it's on your paper. Is this the same thing I wrote on your paper? 17 and 18, 11 to 27 odds? Okay. Well, I gave you a piece of paper. Why would you have to take a picture? I gave it to you. And it's on RenWeb. And it's on YouTube. So there it is. Okay? That's your homework. Do as many of these as you can. When you get to this part, you might struggle a little bit. Just do what you can. And then hopefully I'll have a better explanation for you. And we'll be able to figure out how to do those things right there. Okay?